Pandas has a lot of different ways to parse date times to load in your data. And one of the most common ways, one of the most common file formats probably is a CSV. In your CSV, you typically have comma-separated values that are all stored as strings. Pandas has to read in all of those strings. It then has to attempt to coerce them if necessary. We get all these nice numbers here, you see that? But dates are just a little bit different. If you see here, my data types, all of my numeric columns have been automatically coerced to floats for me. However, my date column is an object. This is what Pandas' way of saying I have not done anything with this column. It is simply just a string. We can manually cast this column into a datetime type column by using the toDatetime function. And with this function, we supply the specific series or column in question here, and we can provide an optional format. Now, this format is not always necessary. However, I would encourage you to always use it. And I'll tell you why. Pandas is never certain of the format that your datetimes are in. In this case, when I print my data here, you can see that I have the year dash the month dash the day, and then a space, and then I have the hours, the minutes, and the second. When I'm looking at data, or when Pandas is reading in data, I supply this format just so Pandas knows what to expect, and it knows how to parse. If I don't tell it how to parse, it will guess. And while Pandas is very good at guessing most of the time, it doesn't hit the nail on the head all the time. In addition to this toDatetime function, we can actually parse dates directly out of the CSV file. Pandas read CSV function is probably has the most keyword arguments in any Python function that I've ever seen. But one of the handy ones here is the parse dates keyword argument. And in this, you can pass actually the column that you want to try and parse, and it'll try a couple different common formats before it guesses correctly and attempts to parse the rest of your values in that column as datetimes. Once you have parsed in your columns as datetimes, you can actually do a lot more than you would kind of intuitively think. In this function, I'm parsing my dates as parsing my column as a date column, and I'm actually setting it as an index. And you can see that here in the output of my data frame, that my index is one level lower than the actual data values. With a datetime index, I'm able to slice and dice this data frame however I see fit. Pandas is incredibly flexible when slicing on a datetime index. I don't actually have to give it datetime values. I can simply pass a string. I can say, Pandas, from this data frame, give me all of the dates that have the year 2019. Additionally, if I do coerce my input into an actual date time, we get a little bit different output here. Instead of getting all of the dates from 2019, we actually just get a single row. And that's because when I do this toDatetime function on 2019, we're actually coercing it to have a start a month of 1, a day of 1, 0 hours, 0 minutes, 0 seconds. And I just so happen to have this key value in my datetime index. Additionally, when I'm parsing with just strings here, I can actually supply also the month. And so now I'm saying, hey, Pandas, give me all of the dates from 2019 in the month of April. And Pandas is incredibly flexible, and it does just that. Again, if I actually pass this in as a date time, this will, again, coerce my date to be April 1st of 2019 at 0 hours, 0 seconds, and 0 minutes. And you can see that if I just pass a less ambiguous string, then I can also extract just a single row. The general rule of thumb here is that the string you pass is if it's a higher fidelity, if it's on the order of years or months and your data is on the order of hours, minutes, seconds, or days, then you'll get back a subset of your data frame. But if you pass something that's at the same fidelity as your data, then you'll get back a single row. And you can see here that my data is in fact in the order of hours. I do have hourly data here, actually every 6 hours to be precise. And so there are a couple other things that you can do when parsing datetimes using .lock. If we pass a date time that doesn't exist, we thankfully get that key error saying, hey, this time does not exist in this datetime index. And again, even if we coerce it to a date time, this still doesn't work. And that's great because since we don't have these data in our data set, we don't want to pull back an empty data frame or anything of that nature. We can also, in addition to just using the ambiguous strings to subset our data, we can also actually perform real slicing. We can pass in February to April of 2019, and we see that we get all of the dates back. Now, this is slightly different than if I just pass a string. If I just pass two strings, I receive all of the dates in February up to April and including all of the dates in April. When I coerce it to a date time first, however, note that I don't get all of the dates in April, I just get up to and including, right, since we're using .lock, up to and including April 1st, since that is my end slice here. And so there are a couple other ways that we can kind of slice and dice our data frames. If I show you this subset here from March to June, we see that I've successfully sliced it. In this case, I'm just pulling out the first column here, so you won't see the whole data set. I can also, instead of using .lock, I can use .truncate. And what this does is just essentially a fancy wrapper around .lock. It's not even that fancy, it doesn't do too much. But this will perform that same type of slicing that you saw earlier, where I get all of the dates in March up to, but not including all of the dates in June, but I do get that first date back. And so it's very similar to if I just pass higher fidelity strings, or less ambiguous strings, I should say, then I can do the same exact slicing. So .truncate's not really needed if you just know how these string accessors, these passing strings in works for .lock. Additionally, like all datetime, or all .lock, I should say, all .lock accessing, you can do fancy indexing where I can simply just go in and grab any 3 random dates or any n random dates just by passing them in. In this case, I'm getting the 6th of March, the 7th of July, and the 3rd of August. September, sorry. Additionally, when we're talking about dates, Pandas has underlying mechanisms that allow us to easily access any part of that date in a vectorized fashion. And all that means is if I create a date range, right, from 2015 to 2017 on the frequency of every week, so this will be every Sunday, right, between these two dates, I can access the year of those dates just by doing .year. I can access each month of those dates using .month, and I can access each day of those dates using .day. And now the day is actually the day of the month. There are ways that you can access the day of the year, right? So it's your scale spans from 1 to 365 instead of just 1 to however many days in that given month. You can also blow up the entire index as an ISO calendar. And so here we can actually see all of my dates, right? We have the same date time index on the left, but you can see that I get the year, the week of the year, and the day of that week that this date falls into. And now this is great when we're dealing with a date time index. And right, we're not always dealing with a date time index object when we're working with Pandas. We typically deal with data in a data frame, or we're dealing with a series. And now a series can have date time index data as its values, or also as its index. And so if we ever have data that's in a series or a column, our data end up looking something a little bit more like this. And right, just to contrast here, all I've done is I've converted this datetime index into a series. And you can see just the difference in the repr is pretty out there. You see on top I have a datetime index and it shows me all of the values, whereas on bottom I just have a vertical series, something we would expect if we just accessed a single column out of a data frame. Now, what's different about this is I cannot access all of the components of the date simply by doing .year, right? I'd no longer have that ability to reach into the datetime values and extract just the year out. Instead, what we need to use is called the datetime accessor. When we're dealing with a series or a column from a pandas data frame that has a datetime data type, we need to use the .dt, this .datetime accessor, in order to access any of those features that we've been showcasing, that we've been seeing on the datetime index object itself. And so here, just by using .dt.year, I can pull out all of the years corresponding to each date, and I could do the same exact thing using .dt.month, .dt.day. And there's even more ways that you can slice your data. Boolean masking is a totally appropriate way of slicing your data when it comes to pandas. And if I want to do something a little bit fancier, right, get all of the rows where the day is 1, I don't have a neat string syntax that I can pass to get all of the rows where the days are 1. Instead, I can reach into the index of my data frame, right? So demand.index, which returns to me a datetime index, and then access the day from that index, and then just create a Boolean mask where all those days are 1. And you can see once I slice that, we get every single date out of my data frame, or every single row out of my data frame that has a day of 1, or is at the beginning of the month. Additionally, I can do this on any level of fidelity that's represented within my data. So I can get the hour, the 12th hour from every single date in my index here. And I can even combine these, right? Get me the 5th day of each month where the hour is 6. And this idea of using, having the flexibility to specify slices based on strings, as well as using Boolean masks, gives us an extremely powerful ability to subset, subselect our data in any way we see fit when we are dealing with date times. One other thing is that you can actually coerce your data into a different level of fidelity. However, what this is actually doing under the hood is not the same as, say, this example where I showed you, get the first day, right, or the 6th hour. This is actually reaching into all of my dates, creating a new datetime index where all of the days are the start of the month. That's what this MS means, month start, spanning from my earliest date to my latest date. Every single month, get the month start, and then it's re-indexing my data frame. And so what this ends up doing is actually pulling out the values that correspond in my original data set to January 1st, hour 00. We're tossing out any other hours with 6, 12, or 18, and just getting that first value, that 00 value. And so I do want you to be careful when you're trying to convert the frequency of your date times, because sometimes it can have unexpected effects. And that takes us to the end of how you can parse dates as well as how you can use them to slice your data any way you see fit in order to subset your data and focus on any relevant areas of interest that you might have.